This is now the question 4 for Edexcel's C4 January 2007 past paper. Now, for question 3, it's asked us to find, it's given us this parametric equation. So we've got an equation for x and an equation for y. Now, I kind of mentioned this in my first attempt at doing this question, which obviously didn't go very well. Not that I didn't know, I just messed it up, but I try not to mess this one up. Take 2, right? Okay, so x is 7 cos t, take cos of 70, and y is 7 sin t, and take 7 sin t, sorry. So sin 70. You see, it's already happened again. That's the 3rd time lucky next time, but I'll have a go at this one, see how it goes. So, I mean, what struck me when I first started this question, well, obviously it says you don't need to simplify your answer for part A. Now, that comes across because we've got 7 cos t and cos of 70, and similarly, basically what we've got is 7 sine of a function, or cos of the function t, and then we've got take the standard function, but it's cos of 7t or sine of 7t. Basically what I'm trying to say is we'll end up with 7 cos t take 7 cos of 7t, for example, or whatever. Basically, it's going to be, I'll shut up. That's what I tried to explain that in my first attempt, but it didn't go very well. Basically, what I'm trying to say is, the reason you don't want to simplify it is because it'll get quite messy if you try to simplify it. But anyway, it's just asked to work out the gradients, asked us to simplify it. Okay, so I wrote it on the board there because I left it on for my first attempt and couldn't be bothered rubbing it off to redraw it again, but I rubbed most of it off, but anyway. Okay, so one of the key things to remember when doing gradient functions for parametric equations is that we don't just use dy dx, because in my language, and maths language, dy dx means the gradient function, and specifically the way I say it, it's the equation of y differentiated in terms of x, okay? I mean, obviously, you know, that kind of makes sense. But when we look at the y equation in parametric form, just a little bit of recap, all we've got is it in terms of t. So if we've got it in terms of t, we can't differentiate it in terms of anything else other than t. So therefore we have to differentiate it with t. And if we do that, then we have to use the chain rule as t being this other unknown variable kind of thing. So we've already got x and y's as unknown variables. But anyway, as I say, it's just a case of following the standard gradient function. Now, a couple of ways this is referred to is the straight differential of y over the differential of x. Because obviously we do the differential of y times it by 1 over x, the differential of x, so therefore we just end up putting the differential of y over the differential of x. It's just that second way kind of a cheating method. I don't know if you're that kind of person, but save you a few seconds in the exam anyway. But I'm just going to do it the long way because, well, I've got loads of time to waste. So anyway, dy dx, okay, so dy dt, now you could write what dy dt is and dt dx is, but I'm just going to follow the formula straight. So dy dt, it's just a case of differentiating the individual terms. So sine of 7t, when you differentiate that, well, the sign doesn't change, but we change it to a cos. We differentiate the t and times it by the whole function. So basically, we times it by 1, so it just becomes 7 cos t. Okay. The sine t, again, on the second part of this stays the same, but we've got sine of 70. So when we differentiate that, we get take 7 cos 7t. Okay, so I've got my writing. And then we times it by 1 over the differential of x with respect to t. Sorry, I just have to take this. I do apologise. I'm a pretty popular guy. Sorry about that. Just this happens. You have to go and talk to contractors and got connections out there. Anyway, right. So we said it's time to dt dx. So dt dx is 1 over dx dt, as we mentioned. So the differential of 7 cos t, well, the sign changes. So therefore it becomes minus 7 sin t. Now I'm going to put that on the right hand side of the bottom of the denominator because well, we know cos changes sign, so when we differentiate the minus cos 7t, obviously that's going to change to a plus. So we'll just go on to that now. So cos of 7t, when we differentiate that, we get 7 sine 7t. And that's obviously plus, so we write it. So 7 sine 7t. Okay? And then it's just a case of simplifying this down, which is why you can see it's easy just to differentiate y and put it over the differential of x. But that doesn't necessarily always work if you've got, if you haven't got x, you've got t equals some kind of x in some function of x. So it's always cautious by doing it this way. But for those of you trying to shove it in to the last minute, then it's easier just to do differential of y over the differential of x. So it's 7 cos t, take 7 cos 7t, that's all over 7 sine 7t, take 7 sine t. Now, as I said, the reason they said leave it in an unsimplified form, or don't simplify it, is because we know sine over cos is tan, so therefore cos over sine is cot, or 1 over tan, and because we've not got a single angle, or we've not got a constant angle in terms of, we've not got it all in terms of t, or all in terms of 7t, it would get quite complicated in terms of, you probably have to use the double angle formula to keep narrowing it down so we get all of them as a single angle, and then work it out in terms of, okay, well what actually then does that translate into a single trig function? And that'd be way too much effort, and you know, it probably would be quite difficult. But if you want to have a go at that in your own time, you know, that's perfectly fine as well. You would definitely use the double angle formula, not necessarily, sorry, not the double angle formula, the addition formula that, you know, leads us to our double angle identities, but we can use them, the addition formula to be able to work out what sine of 7t is, or sine of 7x is. But as I said, you don't need to worry about that for this question. So I don't know why I was going on about it. Okay, part B. Part B says find the equation of the normal to the curve at the point where t is pi on 6. So the first thing you'd write down is obviously t is equal to pi on 6. Just, well, maybe not, but that's what I write down. Now, we know we need to approach this as we would approach a C1 question. So if we had if this was a question in C1, say this wasn't a parametric function, we just had a value for y, a value for x, and we just worked out the gradient function. Well, what we need to know is we need to know what x is. We need to know what y is, and we need to know what the gradient is. So therefore we could put all these ideas into the gradient equation, or the equation of a line, and work it out as so. But the gradient of a normal is the negative reciprocal of the gradient of the curve at that point. So there's a number of ways that you can go around using this information. So what you could do, now remember this is the gradient of the curve, this is not the gradient of the normal. So there's a couple of ways that you, as I said, you could do this. I'll name both of them and then I'll go through the most obvious one. What you could do, what you would naturally do, is use t, sub it in there, get the gradient for the curve, work out whatever answer that might be, do the negative reciprocal of that, and then just use the standard equation for a straight line. By obviously getting values for, and get values for x and y, so by subbing in t to the two corresponding equations, and then using the standard C1 equation of a line and work and simplifying it, etc. Or in a slightly different method, what you could do, we know it's a negative reciprocal, so you could go ahead and work out the gradient for the normal curve. So what you would do is obviously flip the dy dx, so instead of 7 cos t, take 7 cos 7t over 7 sine 7t, take 7 sine t, you would flip it, and then you would do the negative of it, because because it's the negative reciprocal, so you flip the fraction and then you take the negative version of it. Okay, so if you were to do that, so I've just said what the fraction flipped would be, then you just times the individual terms by -1 and you get an answer. So it would be 7 sine t, take 7 sine 7t, and then on the bottom we would have, so it's just turning them around really, you would have 7 cos 7t, take 7 cos t. But what I'm going to do is what you would naturally do in this situation, and just sub in t, get the gradient for the curve and do the negative reciprocal of it. Either way, as I said, it's just up to you if you want to try that other method. I think it's on the mark scheme, but that's, if you're running out of time, that's one of the ways that you could do it. Okay, so we just work out the gradient of the curve at this point. That's the main way, the first method I said, which is the method I'm going to follow. So it's 7 cos t, cos being pi on 6, so it's 7 cos pi on 6, take 7 cos 7 pi on 6, and that's all over 7 sine 7t, which is 7 pi on 6, take 7 sine pi on 6. Okay. Now it wants the answer in exact form, so what you might want to do, instead of just shoving that all in your calculator, because I mean, I think on this occasion it does give you obviously an exact answer just means one that is not decimal. We've mentioned that before. You know, it's just a simple case of working. Well, what is as I said, this is the way I would do it. I do it somewhere else on your page. Obviously, you know, I have a big whiteboard, but I suddenly don't have enough room for this little idea that I did it in my exams. As I said, it's just a heads up. What I would work to do, you know, if your calculator didn't give you an exact answer, work out what cos of pi on 6 is, what cos of 7 pi on 6 is, what sine of 7 pi on 6, and what sine of pi on 6 is. So work out the individual terms. Obviously, you know, it's times by 7 for all of them. So just work out what they are and then sub them in. So if you, obviously we're in radians, you should be aware of that because we're talking in terms of pi, so I forgot to mention that. Okay, so what you would do therefore is, so I'll read out what the values that I got for the functions of trig. So I got cos of pi on 6 to be root 3 on 2, or root 3 over 2, sine of pi on 6 to be a half, and then the corresponding cos 7 pi on 6 and sine 7 pi on 6 are just the negative versions. So cos of 7 pi on 6 is negative root 3 on 2, and sine of 7 pi on 6 is negative a half. Just as cos pi on 6 is root 3 on 2, and sine pi on 6 is a half, as I mentioned. Okay, so it's just a case of subbing them values into the equation. As I said, you could just come up with an answer straight away, and if you were to do that, you should get an answer of negative root 3. But I'll just, as I said, it's always nice to be able to show it properly. So, as I said, it's cos of pi on 6 is root 3 on 2, so it's 7 times root 3 on 2. Take away, now cos of 7 pi on 6, we said was negative root 3 on 2, so obviously this is going to be a double negative, so you just add 7 root 3 on 2. Alright, sine of 7 pi on 6 is negative a half, so it's 7 times negative a half. Take away 7 times a half. Okay, so therefore we end up with 14 root 3 on 2 for the numerator, and then on the denominator we have negative 7. Okay, so therefore that obviously all cancels down quite nicely to negative root 3. But remember, that's the gradient of the curve, not the gradient of the normal. The gradient of the normal is the negative reciprocal of the gradient of the curve at that point. So just to go over it again, as I said, I'm sure I've mentioned it already, what you do is you just you flip the fraction and take the negative version of it. So you should get the official, the gradient of the normal, so m is, because this is negative root 3 over 1, obviously therefore we get positive 1 over root 3, or just 1 over root 3. Okay, so now we've got the gradient. As I said, you could have done that after finding out what your So just make sure I've got the gradient right. Oh, right, sorry. By the way, this 1 over root 3, they also class it as, if you wanted to write it as root 3 over 3, sorry, you'd get the same answer. Sorry, it was just, that answer was winding me up a bit. Okay, so, as I said, we've got a value for t, so we just sub it into the equation for x and the equation for y, because we already know the gradient, which was, as I said, 1 over root 3 or root 3 over 3. So mean the same thing. It's just, if you would have put it in your calculator, you probably would have got the latter answer. Okay, so x equals 7 cos t, which is pi on 6. Take cos of 7t, which is cos of 7 pi on 6. Okay, so therefore the value for x would be, now as I said, cos of pi on 6 is root 3 on 2. So it's 7 times root 3 on 2. So it's 7 root 3 on 2. Take, now it's just cos of 7 pi on 6, which we said was negative root 3 on 2. But because this is double negative, we add root 3 on 2. Okay, so you get a value for x, so it's 7 root 3 on 2 plus root 3 on 2, so it's 8 root 3 on 2. Or if you want to simplify it down, 4 root 3 for x. For y is again similar kind of method, so you just sub in t in the y equation, so it's 7 sine pi on 6, take sine of 7 pi on 6. Okay, we know sine of pi on 6 is negative half, so it's 7 times negative half. Take sine of 7 pi on 6, which we know is, pi on 6, is, sorry, I do apologise. Sine of 7 pi on 6, that's embarrassing. Sine of pi on 6 is positive half, not negative. But sine of 7 pi on 6 is negative half, so it's a double negative again, so it's you add a half. I do apologise about that. So it's 7 times a half plus a half, so that's 8 over 2 or 4 to simplify. Okay, so we've got our values for x, y and the gradient. Okay, so now it's just a case of putting them into the C1 equation of the line and finding the, well, equation of the line.